here we go. We have a question, minimum time to repair cars. You are given an integer array ranks representing the rank of some mechanics. Rank I is the rank of the ith mechanic. A mechanic with rank R means the ith element is the rank R. So that mechanic can repair n cars in r cross n square minutes. Okay, so suppose uh, this mechanic will repair one car. So how much time it will take? It will take rank multiply number of cars square. So rank means 4 multiply 1 square. If he wants to repair 2 cars, so it will be 4 multiply 2 square. If he wants to repair 10 cars, it will be 4 cross 10 square. Then you are also given an integer array cars representing the total number of cars waiting in the garage to be repaired. We need to return the minimum time taken to repair all the cars. All the mechanics can repair the car simultaneously. Okay, so we have given 4 rank mechanics and there are 10 cars waiting to be repaired. So this mechanic with the rank R can repair 10 cars in 4 cross 10 square minutes, so it will be 400 minutes. So if he individually will repair 10 cars, it will take 400 minutes. If this mechanic will try to repair one car on its own, it will take rank multiply n square minutes, so it will be 100 minutes. So 400 for this, 100 for this, but I am talking for one individual person. But we have 4 mechanics and these 4 mechanics can do the work simultaneously. Okay, so it will take 60 minutes only. If 4 mechanic will try to repair only 10 cars, so it will take only 16 minutes, right? And same for this, if we have only 3 mechanics and these mechanics try to repair the 6 cars, it will take 16 minutes. Okay, so let me pick this test case and try to build the approach. So we have given 4 2 3 1 and cars is 10, right? So we have this mechanic, we have this mechanic. What is the maximum time, what is the maximum time that we can give surety that these 10 cars will be repaired? Okay, so this, if this mechanic only means the lowest rank mechanic will repair all cars, right? So it will take rank multiply n square minutes, rank multiply, so let me change the color and write it here. It will take him r cross n square minutes. Okay, so lowest rank is 1 and minimum time, or we can say the maximum time, this is the maximum time because this is for only one mechanic, the load is onto only one mechanic, but we have 4 mechanics, so the time can be distributed, the cars can be distributed, so maximum time is only r cross n square minutes, which is 1 multiply 10 square minutes, which is 100. This is the maximum time. What is the lowest time? Lowest time? So let's assume 1 only. Lowest time is 1 only. Highest time is 100 only. Okay, so we have these and these times, and between this range there is some index which is the minimum index that we can give surety that this much time is enough to repair 10 cars, right? So we know on the worst case it will take him 100 minutes, but we want to find out the minimum time to repair 10 cars. Okay, so how much time? So let me change the question. So if time is only one, time is only one, if time is only one, how much cars, how much cars this mechanic can repair? So we have r cross n square, which is the rank, which is the number of cars, and this is the time, right? So we have this equation. So let me erase this, and we have rank multiply n square is equal to time. This much time will be taken, and I am saying is, if I have only 1 minute, if my time is only one, and we have this many ranks, how many cars can he repair? How many cars can be repaired? How many cars can be repaired under 1 minute? So it will be by r, and write like this. Then the question becomes, under 1 minute, how many cars can be repaired? Can be repaired. So what about this? If time is only one, how many cars can he repair? So time is 1, rank is 4, upon this, which is 1 by 4, which is 0 point something something, and under root of this is very less, so let's assume 0 only. So 0 cars will be repaired for this, right? 0 car for this, 0 car for this, and 0 car for this. 1 by 1 is 1 only. 1 by 1, 1 is the time, rank is 1, under root of this. So 1 under root of this is 1 only. So only 1 car can be repaired. Only 1 car can be repaired. But I want to repair 10 cars. So 1 is not sufficient. 1 is not sufficient. What about 2? 2 is also not sufficient. 3 is also not sufficient. But there is some given index that is sufficient, and after that all the elements is sufficient. 10 minute, I can give a surety that 100 minutes is more than sufficient, but we want to find the minimum index. So can we apply binary search? Because upon some index there are crosses, and after that index there are ticks, so we can surely apply binary search, right? So let's first find the mid. What is the mid? Mid will be 50. How many cars will be repaired if we have 50 time? So 50 by 4 under root, 50 by 2 under root, 50 by 3 under root, 50 by 1 under root, right? Yes, 50 by 1 under root, and it is time by rank. This is our formula, right? So we have taken this, and what is this value? So 50 by this is 1 point something, 1, and 2, so which is 2 3, 3 point something, right? And 25, which is 5, and by 3, which is 20, which is more, right? So so let's calculate it. Okay, let's calculate it. I think this is 4, 3 plus 4 plus so let's cancel out this 3, then 20, 18, right? So 18 under root is 4, 4 point something, so it will be 4 plus 50, which is 50 under root is 7, right? So we have this many cars can be repaired, which is enough. I only want to repair 10 cars, but we can repair 10 cars or more than 10 cars. So 50 is sufficient. 50 is sufficient. Our answer can be 50, or it is less than 50, right? So I can change my R, and I want to find the minimum value. So let's find for 49. We are moving on the left hand side. Then again find your mid value. Mid is 25. Mid is 25. So I have this. I have 25 minutes. How many cars can be repaired? So 25 by 4 under root plus 25 by 2 under root plus 25 by 3 under root plus 25 by 1 under root, which is still more than 10. I think uh, we have by 4, so it will be 4 6 6 point something, and it will be 2, and 12, which is 12 under root is 3 3 point something, and is 8, which is 2, then 5, which is still more than 10, which is still more than 10. So 25 is another answer, or the answer is less than 25, right? So 25 is a better answer, or the answer is less than 25. Again find your mid. Again find what will be our answer. 25, which is 12. So 12 is also a valid answer. Let me give you shorty. We don't need to calculate it. 25 is still a valid answer. Because yes, the actual answer is 16. So 20. Okay, so we have 12, right? We have 12, not 25. We have 12 minutes. Under 12 minutes, how many cars can be repaired? Can be repaired. And my answer is 25 for now. And I am checking for 12 minutes. Under 12 minutes, how many cars can be repaired? So it will be 3, which is 3 under root is 1 point something. So I am taking 1, and then 2, and 4 for I am taking 2, and 12 under root is 4, which is 3. So only 8 cars can be repaired, but I want to repair 10 cars. So 12 is not a answer. The answer is more than 12. The answer is more than 12. So what I am saying is, if cars repaired is less than, it means I can repair only 8 cars, but 8 cars is not sufficient. I want to repair 10 cars. If cars to be repaired is less than the given cars, I want to move on to the right hand side. Else the cars can be repaired, the 10 cars can be repaired, or more than 10 cars can be repaired. So mid is a valid answer. Mid minutes is a valid answer, or we are trying to find the minimum time. So I am going on the left hand side. So this will be my equation, right? And I want to calculate these cars to be repaired in a separate function. So let's code this. So first let's find L and R. Min dot so 1 second. Okay, so using this I can find my minimum value. So this, and this is the minimum, right? So what is the lowest time? Lowest time is 1. It will take 1 time, so I am accessing for 1 only. Then what is the maximum time that it will be taken? So I have given 10 cars, and I have found the minimum value multiply n square. So number of cars, n is the number of cars multiply cars minimum. But minimum and multiply cars can be integer overflow, so I have to take long, and one long multiply, so now it is a long value. And let's also take answer while l less than r or equal to r, then long find the mid. Okay, then I need to find how many cars can be repaired under mid minutes. Okay, so integer cars repaired, calculate ranks and mid int, and this is the time. We have a formula, rank multiply cars is equal to time. Then it will be cars multiply cars is time divide ranks, and cars will be time divide ranks की power 0.5 means under root. So cars repaired is 0 initially, then we have a, then cars plus equal to time is mid time only, then rank, so this is the rank math dot power 0.5, return cars. But to be on a safer side, I will take long. If I can repair more than or equal to cars, so this is a valid answer. My answer is mid minutes, or I need to find minimum time. So the requirement is to find minimum time, or if this much time is not sufficient, we need to increment the time, we need to move on the right hand side, and that's enough. This is not rank, this is not nums, this is ranks, and mid is long, time is long. Yes, working. Let's submit this. Yes, working fine. Let's discuss about the time and space complexity. So while loop is for binary search, and it will be the minimum multiply cars. So this is the upper bound for this, and inside this we have calculate function which is order of n, and this is the log of the upper bound. Upper bound is minimum multiply rank, minimum multiply cars, and inside this we have log of n. So that's about the time complexity. Space in this case is constant, space is order of 1 only, and that's all. And the code is provided in the description box if you want to check out. That's all. Thank you all for watching this video.